Hi everyone, in today's class we'll see JK flip excitation table and also the state diagram. Guys, in the earlier classes we have seen how to derive the characteristic table for the JK flip and also we have drawn the circuit diagram for the JK flip. We have also derived function table for the JK flip, right? Now in today's class we'll draw excitation table for the JK flip. Right, so the meaning of excitation table is, if you are going to give the qn plus 1 as values, you can able to define what might be the inputs. That kind of table I can call it as excitation table. Means here we are going to have two inputs, one is qn, another one is qn plus 1. I can simply say that one is present state, another one is the next state, right? Now we need to define what might be the inputs, right? So if you are going to have two variables, you are going to get four possibilities. One is 0 0, 0 1, 1 0 and 1 1, right? So when you are going to have 0 0, what might be happening, right? Try to think. If I am going to have 0 0 as qn and qn plus 1, j and k are 0 0, but this is not only one case, right? We might have multiple cases. Here also 0 0 is there. Now what will happen? Meaning that when 0 0 are there, how your inputs are behaving? One is 0 0, another one is 0 1, right? Means one is 0 0, another one is 0 1. Can I write these two as one don't care? Means I can combine 0 comma don't care. If I write 0 and don't care, in SR flip-flop also we have explained clearly, right? 0 don't care. What is the meaning of this one? I can write this as 0 0 or I can write as this one 0 1, right? That is what I am trying to write here. Okay, fine. Try to observe. Now if I am going to have 0 1 as inputs, 0 1 as input, meaning that 0 1 is there. Is there another 0 1 is there? Yes, 0 1 is there. Now how can we write? Can write it as this 1 0 and 1 1, 1 1 are common. This one I can write as pi. So I can write as 1 pi. Means I can write as 1 0 1 1. So this is the corresponding expected output for qn plus 1. Similarly, if we take 1 0 as input, this is 1 0 and this will be the 1 0. Means we here also we have two possibilities are there. One is 0 1, another one is 1 1. So can I write as pi 1? Yes. Means I can write as 0 1 or 1 1 right? Similarly I am going to have one more possibility is there, 1 1. When you are going to have 1 1 as the qn and qn plus 1, your j and k values are 0 0 and 1 0. So I can write as pi and 0. I can write this also as 0 0 1 0. Right? If you are able to observe, all the 8 values are derived, even we reduce it to 4 level, right? So this is the corresponding excitation table for the JK flip, right? Next, let us try to draw the state diagram for this, right? So guys, state diagram means basically it will define on which state if you are going to give separate input, if you are going to give some kind of input, which state it will move, that is what you can call a state diagram. Meaning that, for example, if you are able to assume qn as 0, qn plus 1 as 1, meaning that here we are going to have two states. I am going to give those two states names as 0 and 1. 0 is one state and 1 is one more state, right? Now observe, if I am going to present at the state 0, I am going to present at the state 0. If I get the inputs 0 0, from which state I will move? I will move to the 0 only, right? Means if I am going to have be 0 0, if I got the inputs as 0 0, I will move to the same state only, that is 0 only. Okay. if I have present at 1 1, if I get the inputs as 0 0, I am going to go to 1 only. So here 0 0, you are going to move to 1. Similarly, if I am going to be present at 0, what might be the next state is also 0 for the input of 0 1. Input of 0 1, meaning that if I am going to be present at 0, if I got the inputs as 0 1 also, I am going to be present at the same state. I am not going to move to the other state, right? Similarly, if I am going to have the present state as 1, if I got the input as 0 1, I will move to the 0th state, right? Meaning that if I am present at the 1 state, if I got 0 1 as input, 0 1 as input, I will be moved to the 0th location. Similarly, if I got present at the 0th state, if I am moving for trying to move to the next state based on the certain input, like if I got 1 0, I am moving to 1 state, meaning that if I am present at 0th state, if I am going to get the input as 1 0, I am moving to first state. Done. Right? If I am present at the first state, if I got the input as 1 0, I am going to move it to first state only. So I can be written there like this only, right? Similarly, if I am presently at 0th state, if I got the input 1 1, I am moving to 1 state. So if I am at 0th state, if I am having 1 1, if I am at 0th state, if I am having 1 1, means I am moving to first state. Okay. Similarly, if I am going to be present at 1 state, if I got the 1 1 as input, I am going to go to 0th state, meaning that if I get 1 1 as input, I am going to move it to the 0th state. Okay. So this is what we can call it as state diagram. So the same way you can able to write for various kind of other flip-flops also. See, the simple thing is if I am asking you, like if I am present at the, if my QS is 1 1, see, if my QN is 1, what might be the Qn plus 1? On the values of 0 1 when J and K are 0 1. Can you able to derive with the help of this respect to state diagram? Yes, right? So try to observe. If I am at 1, I got input as 0 1. Where is 0 1? This one, 0 1. So I am simply moving to 0. So I can write as Qn plus 1 as 0. Means if you are able to observe 0 1, what might be the Qn? 1. So you are getting the 0. So that is what, right? So the same kind of JK flip I can able to represent in different ways. One is through definitely represent as a in the form of characteristic table. Another one is I can represent in the form of characteristic equation. Another one is I can represent in the form of excitation table. Another one is I can represent in the form of state diagram. And one more thing is we can able to define in the form of function table. These are the many ways we can able to represent any kind of flip-flop. Okay, I hope you understood clearly. Thank you.